Good morning, all. Am I audible, man?
Morning, sir.
Hello.
Yes, sir.
Yes, sir.
Good morning, sir. Yes, sir, you are audible, sir.
So, all are fine.
Yes, sir, we are fine, sir.
Yes, sir.
The moment I posted I want to take first year classes, my mother, sister, all got affected with COVID. So, it's became a big headache for me to coordinate all this. So, I couldn't take the classes. Anyhow, now I will compensate that. So, what is the last class we are discussing, man?
Gold leaf.
Gold leaf,
Electroscope.
sir.
Completed, that one?
Okay,
Sir.
sir.
Just read the last words of Gorley's experiment.
If the leaves diverge, body is electrically charged. If there is no divergence, body has no charge.
Okay, right.
Gold leaf electroscope.
Hello?
Yes, sir.
I think you enjoyed your festival well.
Yes, sir, enjoyed, sir.
Now let us get back to the work. Gold electroscope. 1 second. Did I give that identification of charge? Right.
Yes, sir. Yes, sir.
How to identify charge? Did I tell you? Gold electroscope. Let
No,
us see.
no, sir. You didn't tell, sir.
See, detection of charge you discussed. Identification of charge you should know. So here,
Yeah,
see, suppose this is, I'm just showing this disc. Remember the gold leaf electroscope, it has two leaves. Okay. So we'll first charge the electroscope. That means remove some electron, it becomes positive. So this will be the positive one.
yes, sir.
Okay. Now we take, I'll bring another body here. Now you can see the leaves diverge. Why does it? It means leaves move farther apart. Do you agree with this?
Yes, sir.
Yes, sir.
That means this body should be
Positive. Positive.
understood this. This implies body should be what?
Mm, Positively charged.
Hmm. Do you agree with this?
Yes, sir.
Yes, sir. Agree, sir.
No, 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 no. One second. Will you turn this?
Sir, 1 minute, sir, please. 1 minute.
So I can put like this. This is positive charge. So some electrons go away. This will become more positive. Now suppose we have a situation wherein theta decreases. So when they converge, this implies that do you agree with this?
Yes, sir.
So this is how we can test the nature of charge on a body using an electroscope. Shall I turn this?
Minutes.
Sir,
Minute, sir.
sir, 1 minute, sir. Yes.
Completed?
Yes, sir.
Yes, sir.
Sir, 1 minute, sir, please, sir. 1 minute. Yes, sir. Completed, sir.
So this is
Completed.
the process of identification by conduction. Conduction means by touching.
Yes.
Shall I turn this?
Yes, sir. Completed, sir.
Now we can even identify the charge by induction. Say for example, this is the charge, this is theta. Okay. Now when you bring a body which is positive, what will happen to this? Can you tell? When you bring nearer it, which charge will be induced?
Sir, negative charge will
So
accumulate.
here this will be negative. So at the farther end, what will happen? Positive, no?
Positive. Yes, sir.
Yes, sir.
So here you can see negative charge is induced. Follow this?
Yes, sir.
Now suppose, so divergence angle increases now.
Uh, sir, that I didn't understand, sir.
Tell.
How this divergence is increasing, sir? Because,
Pardon?
sir,
See,
sir, I'm not.
earlier you have seen that suppose this is some body. You bring in a
Yes,
positive one. The nearest part will have negative. Farthest part will have positive. Remember all that?
yes, sir. Remember, sir. Remember.
Same thing. Nearest is this, no? This is the
Yes, sir.
farthest.
Sir, so the farthest won't
Yes.
affect the gold leaf, the positive
Pardon?
charge. The farthest part won't affect the gold leaf.
Which positive part?
The
Which will
positive
no
and
no man. You try to understand which is nearer. This one. This also will get affected, but it's far away, no?
Yes, sir.
Agreed or
Very
not?
far away.
See, you are attracted even by the sun, but that is negligible. Which is dominating? Gravitational pull
earth.
of the earth is dominating, no?
Yes, sir, yes.
Yes, sir. Yes,
So
sir.
what dominates phenomenon occurs over that only, no? Agreed or not? Even in
Yes, sir.
daily life
Agree, sir.
also, certain things will dominate. You know something is good, something is bad, but some people do bad because at that time the mind is dominated by those thoughts. Now suppose I bring a negative one. What will be induced here nearest?
Positive.
Positive. So here this will be less positive, no? So what will happen? Divergence angle will decrease. Due to negative induced charge, what will happen? Net positive charge decreases. So what will happen? This theta will decrease. Understood this? So this
Yes,
is
sir.
how this is by induction. Induction means you are not touching. Understood this or not? Is it clear?
Sir.
Yes, sir.
Clear.
It is clear.
Shall I turn this?
1 minute, sir.
Sir, 1 minute, sir. Please.
Completed man.
Sir, 1 minute.
1 minute.
Sir, 1 minute, sir. Please.
Completed.
Yes, sir.
Yes, sir. Completed, sir. Complete.
See, actually this became obsolete. It is in series, oldest we have two things. One is ESU units. Is of charge. This means electrostatic unit, okay, called stat coulomb, okay, and you have second one is EMU of charge, means electromagnetic unit, electro called ab coulomb, okay. So remember that. So the conversions are one EMU of charge, one ab coulomb is 3 into 10 power 8 stat coulomb, 1 coulomb. Coulomb means SI unit. 3 into 10 power 9 stat coulomb, okay, and 1 ab coulomb is 10 coulomb. Understood this? And remember that these are they have become obsolete, no more they are using. But why I gave is, if you refer to some books, here and there you will come across this word, don't get worried. It is only, again you may feel that you don't know something. These are not required for any examination. Understood this? So we still adopt only essay system. Is it clear?
Yes, sir.
Shall I
Yes,
turn
sir.
this?
Yes, sir.
Sir, 1 minute, sir, please.
Right, sir.
1 minute.
Because in somewhere in that NCERT book or somewhere, these words have been appearing in numericals. Again, you'll feel something diffident, no? Psychology is that you feel that you don't know anything in physics. If you don't know one word, you'll feel like that. Just for that continuity's sake, I'm giving. Other than that, there is no use of this. Shall I go ahead?
Yes, sir. Completed, sir.
Right. See, this is similar to your gravitation chapter we have seen. The same methodology will be adopting here. See, here this is given as force between two point charges by distance r is, this F is proportional to the product of the charges, just like how you have M1, M2 inversely proportional to this. So if you club this, I can say that F is proportional to Q1, Q2 by R square. F is some constant of proportionality into Q1, Q2 by R square. Follow this?
Yes,
So
sir.
here, this constant of proportionality depends upon the system of units. And also on medium between the two charges. So if in vacuum, that means there is no medium. If charges are at a separation, okay, then the force is Q1 Q2 by R square in series system. Okay, here we can have constant is 1, Q1 and Q2 are in centimeter, F will be in time. Understood this? Now suppose, shall I turn this?
1 minute, sir.
1 minute.
Completed?
Sir, 1 minute, sir, please. 1
1
minute.
minute, sir.
Sir, this won't be constant in unit, right?
Constant is 1, not that it won't be, it is there, the value is 1.
Sorry, sir, yes, sir. It won't be
Not
one
there
in-
means constant must be 0.
Yes,
Am
sir.
I right?
Yes,
Sorry.
yes, sir.
Shall I turn this?
Yes, sir. Completed, sir. Completed.
See, now suppose there is a medium. For example, these are two charges which are in vacuum, they are separated. This is the repulsive force. Force on 1 due to 2. This is the force on 2 due to 1. What is F12? Force on Q1 due to
Q2. Q2.
Q2. Do you agree with this or not?
Yes, sir. Agree, sir.
Agreed.
Next. Similarly, F21 is force on Q2 due to Q1. Okay, if Q1, Q2 are here, Q1, Q2 are
Point charges.
vacuum. So now you can see that that force is nothing but the magnitude of force. Just now you have seen that in SI. This is the where in SI system, okay, we have if there is no medium, that means vacuum. What is the constant value is
1/4 pi epsilon.
understood this? So what are these all these in due course of time you'll be understanding one by one because up to alternating currents all these are interlinked. So here I'll just give you what is necessary, then slowly I'll develop this. Till here there is one thing called constant. What are these all these I'll explain. Wait. Till here you followed? Clear? So now
Yes, sir. Clear, sir.
what happens if there is a medium? The question naturally arises. Definitely these are will this force change? F1, this will not change. Do you agree with this? This
Yes, sir.
will not change. But suppose I bring a body like this. Example I am saying. When I bring a body here, this positive and this positive will induce what? Negative, no? Induction is taking place or not?
Yes, sir. Yes, sir.
So naturally there is a force between these two, no?
Yes, sir. There will
This
be.
I
Yes,
this
sir.
is I'll call it as force due to the medium on body 2. This is force due to the medium on body 1. Do you agree with this? Now imagine this. Now you can see that if we go on increasing the medium, that means this is the small, I'll go on increasing this. What will happen? Definitely the medium will affect this now.
Yes,
Agreed or
sir.
not?
Yes, sir.
That
Yes,
means
sir. I
the
agree.
presence of a medium will change net force on each charge. Do you agree with this? That means I can say net force in medium. Okay, will be given by 1 by 4 pi. This is called epsilon q1 q2 by r square. So remember this is called as epsilon. Okay, this symbol
Yes, sir.
just like alpha, beta, gamma like that. Epsilon. What are these? Let us see. Understood this? So here you can see that
Yes, sir.
F net is nothing but the vector sum of these, no?
Yes, sir. Yes, sir.
That is also equal to what? F21 plus medium also affect that also, no?
Yes, sir.
Is it clear?
Yes,
Yes,
sir.
sir.
It is clear, sir.
So whenever the presence of a medium definitely changes the force.
So, one doubt, sir. So we
Tell.
have to add this entire thing, no, sir. Means F12 plus F medium with respect to then plus F21. Like that we have to add, no, sir. All four forces we have to
Please
add.
repeat the question once again.
So we have to, for getting net force, we have to add those four forces, no, sir.
No, no, on each charge this is net force on each charge.
Uh, yes, sir. Yes, sir. Yes, sir.
Not the net force on the system. If you take on the system, net force will be zero, no, because they are action reaction pair.
Yes, sir. Yes, sir. Yes, sir. Understood, sir. Clear, sir.
So the thing you have to remember here is the presence of medium will definitely decrease the force. Agreed?
Yes, sir.
Yes, sir.
Agreed,
Agree,
sir.
sir.
Shall I turn this?
One
Sir,
minute.
1 minute, sir. Please. Yes, sir. Completed, sir.
1 minute, sir. 1 minute.
Sir.
Sorry.
Tell me.
Uh, sir, sir. Uh, I said completed, sir. Just before.
Yes. Right. Shall I go ahead, man?
Yes.
Yes, sir.
Yes, sir.
Complete.
So simply we can say that suppose there are two charges. So what we learned is there will be a force between them. This is force between the charges. So whenever the charges are placed in a medium, you can see that due to polarization of the molecules of the medium, you have just now seen that there will be a force to the medium. No?
Yes, sir. Yes.
Do you agree with this?
Yes, sir. Agree, sir.
So therefore, I can say that there is a net force. No? So the net force will be. Do you agree with this?
Yes,
So
sir.
I can
Agree,
say
sir.
that I can say that F net is the reduced value. Do you agree with this or not? Is it clear?
Yes, sir. Clear, sir.
So now I can say that the presence, this polarization is affecting this now. Do you
Yes,
agree
sir.
with this or not?
Yes, sir. Yes, sir. Agree, sir.
Shall I turn this?
Sir, 1 minute, sir. Please, sir. 1 minute. Yes,
So I can
complete.
say that when charges are submerged in a medium, the force exerted by one charge on another does not change. But what will happen?
Net
Yes.
force on each molecule changes. Sorry, on each charge. Yes.
It is decreases, no?
Yes, sir.
Yes, sir.
Decreases.
Shall I turn this?
1 minute, sir.
Then won't the FM be in the direction of the force as well because the medium is all over, right? Because it's submerged.
Hmm.
So there will be
No.
addition of molecules.
This is the medium, no? We are talking only about the influence of the medium between these because force is between them, no?
Okay, sir. Not the full medium around it.
Mhm.
It's medium. Okay, sir. Understood.
Just like frankly speaking, this is a vector one. The direction is not known. Okay, and we can keep like this. It may be in any direction. Accordingly, you use vectors law. Okay.
Yes, sir.
Yes.
Yes,
Yes,
sir.
sir.
Shall I turn this?
1 minute, sir.
So remember that the moral of this whole discussion story is whenever charges are in a medium, the Coulombic force between the on each charge will decrease.
Yes,
Finished?
sir. Yes, sir. Complete.
So now can you tell why this is decreasing? Which is what is the cause of this? Medium polarization, no? That
Yes, sir.
means every medium has one property. We represent this as absolute permittivity. Of medium. Okay, it is the property of a material or a medium that affects the Coulombic understood this? See, for example, hello.
Yes,
Yes,
sir.
sir.
This actually, whenever medium is there, is a polarization. Remember, all media are not equally polarized. No. For example, students, if you take some people, if you tell good things, they get polarized. Some people, if you tell any number of good things, they won't bother because they won't get polarized. They have negative inductive effect. They get polarized due to negative thoughts. Okay, that means each material has a unique property. So some materials can easily be polarized. For example, if you keep wood cannot be easily polarized because the molecules cannot be oriented so easily. On the other hand, if you keep some metal, polarization is easy. So that depends upon medium. Understood this? So only thing we can
Yes,
say
sir.
is Coulomb force is maximum when charges are in vacuum, also called as free space. Understood this? Is it clear?
Yes,
Clear, sir.
clear, sir. It's clear.
So this E depends, epsilon depends upon the material. Is it clear?
Yes, sir.
Yes, it's clear, sir.
So I can say that when two point charges are placed at a separation R in vacuum, 1 by 4 pi epsilon naught, where epsilon naught is permittivity of vacuum. This is nothing but its value is 8.85 into 10 power minus 12. So you can get that now. What are the units of this? Coulomb, Coulomb. Coulomb square by, if you bring this side, what will get? Newton into meter square. Remember this?
Remember, sir. Remember.
Yes, sir.
Yes, sir.
Remember.
Now if you take your calculator, pi value no 3.1 for substitute this, this nearly comes to 9 into 10 power 9. Okay. So this value if you need, the units of this is meter square by Coulomb square. Is it clear?
Yes, sir.
Yes, sir.
Shall I turn this?
1 minute.
Sir. 1 minute, sir. Please, sir. 1 minute.
Completed?
Yes, sir.
Yes, sir. Complete. Completed.
So now suppose if the charges are placed then Coulombic force four pi epsilon naught k. Okay. What is k? Let us see. This is nothing but
Yes.
between charges in vacuum by k. Okay. K is a number. What is that? We shall see that. You can see that epsilon by epsilon naught is called as ER or K. That is dielectric constant relative, like relative density, relative permittivity. That means permittivity as compared to what? Vacuum. Understood this? Or the other name is specific inductive capacity. This is the name. Mostly we'll be using this only. The name we use this only. Okay. Is it clear?
Yes, sir.
Yes, sir. Yes.
Followed this?
Yes, sir.
Shall I turn this?
1 minute.
1 minute, sir. Please, sir. 1 minute.
See, this is all the introduction of Coulomb's law. A lot of long journey for this. So each symbol, their meaning. Finished?
1 minute, sir.
Completed, sir.
Done, sir.
Yes. So what we got is force when the charges are in medium is force when the charges are in vacuum by K. That means I can say that presence of medium decreases understood this. So here for vacuum,
Yes, sir.
what is the relative permittivity? Actually this is nothing but vacuum is this one, what you will get here.
1.
Agreed?
Yes, sir.
Great, sir.
Yes, sir. Agree, sir.
Now suppose we need the dimensions of this. We need the dimensions of this. This is epsilon naught. This is number, no dimensions. This is 1 by F. This is Q, current into time now. Remember that current is Q by T. Current is a fundamental quantity. Okay, this is fundamental. So charge is derived. Time is
Fundamental.
Now,
so if you write only in terms of fundamental, this is nothing but length square. So this is no dimension. This is what? Force dimensions. Mass into acceleration. Remember? So this is nothing but I square T square by L square. See, once they ask a question on dimensions of this in advanced exam, T power 4 I square. Finally, you'll get this. Is it clear?
Yes, sir.
Yes, sir. Clear, sir.
Will I turn this?
1 minute, sir.
1 minute.
Yes, sir.
Now, coming back to this is relative permittivity or dielectric constant. This is nothing but is unitless and dimensionless, no? Yes, both are having same dimensions, no?
Yes, sir.
Yes, sir. Yes, sir.
Is it clear? See,
Yes, sir.
see,
Clear, sir.
is far greater than gravitational force. For example, electrostatic if nothing is mentioned, that means it is medium is vacuum only. Charge on proton. What is that?
1.6 into 10 power minus 19.
Say this is kept at a distance of r square. Okay.
Yes, sir. Yes.
Mass of the proton 9.1 and 10 power 9 into minus 31, I think, no?
Yes, sir. Yes, sir.
Okay, anyway, I'll do one thing. Mass of proton, we don't require this. Okay, now if you take this and if you find out, it will be nearly 10 power 36. This implies F is 10 power 36 times that. Understood this? So very huge value, no? So that is the
Yes,
reason
sir.
why.
Huge well.
Understood this?
Yes, sir.
Next.
Yes, sir. Understood, sir.
Coulombic force is such that force on one is equal and opposite to this. Okay, is it clear? So this is force on do you agree with this?
Yes, sir.
Understood this or not? Always occur in pair only. You cannot have a single force. Let's turn this.
Minutes.
1 minute.
Yes, sir.
Minute.
Sorry, sir.
Shall I turn this?
Yes, sir.
Yes, sir. Complete.
Next. See, just like gravitational forces only, Coulombic forces are also conservative. That means work done in moving under the action of Coulomb's force is what? Zero. Do you agree with this?
Zero. Yes, sir.
Next. See, suppose there are two charges here, Q1, Q2. Say for example, this is F12, this is F21. Okay. Now you can see that F12, so this is the distance between them. Or magnitude wise, just now you have seen that this is nothing but 1 by 4 pi epsilon naught Q1 Q2 by R square. Now suppose we bring another charge here. I keep another charge here, for example. Anyway, say this charge, the separation is some R3, this is some R2, and this will be R1. Now, force between Q1 is nothing but 1 by 4 pi epsilon naught. Similarly, force between this is nothing but, hello?
Yes,
Yes.
sir.
Yes, sir.
Yes, sir.
Do you agree with this?
Yes, sir.
So,
Agree, sir.
still F12 will not change. So what you can infer from this? Agreed or not? That means Coulombic
Yes, sir.
force
Agree.
between two charges does not depend upon the presence or absence of other charges. Do you agree with this?
Yes, sir. Agree, sir.
Shall I turn this?
1 minute, sir.
So 1 minute, please.
Periods.
See here,
Yes. Yes.
Q1 is nothing but due to vector sum of these, no? Similarly, net force
Yes, sir.
on Q2 is what?
F23, sorry, F21 plus F23.
So net force understood this? Is it clear?
Yes,
Yes, sir.
yes, sir. Yes.
Shall I turn this?
Yes, sir.
1 minute, 1 minute.
Sir, 1 minute, sir. Please, 1 minute.
See, your maths class is from 11:15, not 11. Okay. My class will go up to 10:45, 10:50 like that. So you'll be given 20 minutes break. Don't worry. Yesterday I spoke to Abdul also.
Yes, sir.
Don't leave at 10:30 only, because lot of syllabus is the second year. Don't behave like first year students. Second year mostly will focus on outgoing battles. Shall I turn this?
Yes, sir.
Yes, sir.
So what we can conclude is net force on any charge understood this? What is this called?
Yes, sir.
Remember gravitation, we learned this.
Yes, sir. Yes, remember. Understood.
Next. See, suppose this is a charge Q, say this is fixed, for example. Another charge is coming here. Definitely, due to attraction of this is force, no? And this is position vector, no? So this is point 1, point 2. So force on 1 due to 2. Okay. Is how much? Remember? R cross F, no?
Yes, sir. R cross F. Remember, sir.
This is only R, no? About which point you are taking? This is R only, no?
Yes, sir. R.
Therefore, long back you learned this. Remember this? Torque equals dl by dt. If torque is 0, what happens? dl by dt is 0. That means L will be constant. All this you learned. Hope you remember, I think.
Yes, sir.
Yes, sir.
Shall I turn this?
Please wait.
Sir. 1 minute, sir. Please, sir.
Finished?
Yes.
Yes, sir. Completed. Sir.
1
minute.
Completed? H.
Yes,
Now,
sir. Completed.
now,
Sir.
see here, suppose this is one body, there is a charge like this. So this is the center of positive charge. Now whenever we bring a charge here, what will happen due to repulsion between them? This positive charge will be going which side? Away from this, no? You can see that most of the charge will be concentrated here. So this center of charge will shift like this now. So definitely
Yes,
this
sir.
distance, see suppose this charge is Q. Okay. Now this distance is R1, for example. Now suppose this charge is a point charge Q. Will there be any induction? This is R.
No, sir.
Now here what is the force between them?
1 by 4 pi epsilon naught Q1 Q2 by R square.
So definitely in this case force will be what? Less than this, no? Do you agree with this? Any doubt is there? R1 is more, no?
Yes, sir. Yes, sir.
So definitely this will be lesser, no? This value should be lesser than this.
Yes, sir. Yes, sir. Agreed.
Suppose we are bringing a negative charge here. So this is minus Q. What will happen? All the positive charges will be coming this side and very few, 1 or 2 will be left over. That means now the center of charge will be shifting this side now. Say this is R3 or R2. Then this force in this case is more than this now.
Yes, sir.
As R2 is
Greater than R.
less.
Lesser than R.
Understood this?
Yes, sir.
Yes, sir.
So remember that this is validated only if the charges are point charges. Otherwise, you cannot use this. Why? Because the charge distribution on the other bodies may change. Therefore, the distance will vary. Understood, isn't it?
Yes, sir. Understood.
Understood this?
Yes, sir.
Sir, 1 minute, sir. Please, sir. 1 minute.
Shall I turn this?
1 minute, sir.
Sir, 1 minute, please. 1 minute. Yes, sir. Complete, sir.
1 minute, sir. 1 minute.
Fast.
Done, sir.
So I can say that Coulomb's law expresses force between two point charges. Understood this?
Sir.
Yes, sir.
Is it clear?
Yes,
Next
sir.
step. See, whenever we'll see that later in electromagnetic waves. I think you have come across in chemistry also these 3 points. Stationary charges produces electrostatic field. Okay. Whereas an isolated charge in uniform motion produces both magnetic field and electric field. And an accelerated charge produces both what? Magnetic and electric field.
Electric field.
What does it
Releases
do?
energy.
And also
Releases energy.
radiates energy. Electromagnetic waves. Remember this?
Yes, sir.
Yes, sir.
So now suppose if a charge is moving, it produces both electric field and magnetic field, no? So the force on the charge, you cannot tell whether it is electric force or magnetic force. That is the reason why Coulomb's force only is applicable if at least one of the charges is at rest. Understood this? Clear?
Sir.
Yes, sir. Please.
Understood this? Otherwise, what happens? Otherwise, the problem that comes is you have both magnetic force and electric force. Understood this? Is it clear?
Yes.
Yes, sir. Clear, sir.
Shall I turn?
1 minute, sir.
Sir, 1 minute, sir. Please, sir. Yes, sir. Completed, sir.
See, if distance of separation r is less than this, which forces will dominate? Van der Waals forces, remember that?
Yes, sir.
Or strong nuclear forces will dominate. Therefore, these forces are not, electric forces almost become negligible. Hello?
Yes, sir.
Sir, Van der Waals
Yes,
forces are
sir.
weak attractions, right?
Pardon?
Van der Waals forces are weak attractions, right?
They are weak attraction. Sorry. Strong, I told Van der Waals, sorry. Strong nuclear forces will come into role. Strongest forces in the universe is what? Nuclear forces,
Nuclear
no?
forces.
Yes.
They dominate at a distance of 1 femtometer. Femto is 10 power minus 50 only, I think. Agreed? Or 1 Fermi.
Yes, sir. Yes, sir. Agreed, sir.
So remember, it's not Van der Waals forces, it is nuclear forces,
Yes,
which are strongest, and they come into action when the distance of separation is less than 10 power minus 15 meters. We shall see this in nuclear physics. Till here, any doubt is there? Shall I turn this?
Yes.
Yes, sir. Completed.
Another 10 minutes, wait. See here, actually we have that they are not point charges. We have to go opt for integration. But the other way is only in case of a shell. Suppose it's a shell and assume that if this charge is uniformly distributed. Therefore, what will happen? And suppose this is the center of this. Now this you can keep the Q here, just like in gravitation you have done, remember? And you can apply Coulomb's law. Followed this? Hello?
Yes, sir.
yes, sir.
So you can say that a shell Follow this.
Yes, sir.
Now suppose it's a shell. Gravitation field inside a body will be how much? Remember? Gravitational field intensity I inside is how much? 0, remember? Hello?
Yes, sir.
We have electric field intensity. E bar. This is electric force by charge. Okay? As E inside. Therefore, F is 0. That means suppose this is Q. Okay? Following or not?
Following, sir.
Exact. Understood this?
Sir, can you once
Yes,
explain
sir.
bit intensity part?
In gravitation, you studied that inside a shell, there won't be any field. Same way, inside a shell, there won't be any electric field. So whenever electric field is not there, intensity in gravitational field is F by m, no? Same thing in electric field intensity is F by Q. Inside it is 0, force is 0. We shall see what is this, all this slowly. Wait. So only thing for the time being is, any charge inside a shell will not experience any force. Understood this? That means there is no force between these two.
Yes, sir, understood.
That means we can say that I'm telling this is an introduction only, one by one chapters are there. Electric field and separate chapter is there. Till here any doubt is there?
No, sir.
No doubt, sir. Clear.
Shall I turn this?
1 minute, sir. 1 minute.
Sir, 1 minute, sir. Please, sir. Yes, sir. Completed, sir.
What are there? Right.
Followed, sir. Followed.
Now let us see a simple application of all this story we studied. See, suppose it's a shell. There is charge on this Q. At the center, I am keeping a charge Q. Again, at a distance of say R, I am keeping this. Okay. Say all charges are positive. So find understood the question? Quick,
Yes.
tell the answer.
Yes.
Zero.
Hello?
Sir, it's zero. Q due to shell.
It will be 0. That is actually the answer you gave. Remember, that is wrong. Reason is, as
The net force will be more, right? But the inside,
Q will not experience any electrical force. Agreed. Therefore, I can say
Agreed.
net force on Q will be equal to force on Q due to shell, okay, plus force on Q
due to Q dash.
due to Q dash. Anyhow, this is 0, no?
Yes, sir.
Force on Q due to Q dash. So this implies that
Sir, force on Q due to shell is zero only, right?
no, previous case is different. Remember, there is no
Okay,
external
okay.
charges
Yes,
here. That is the reason why don't import. Situation of the problem you should see, no?
yes, sir. Yes, sir. Agreed, agreed. Sorry, sir.
So this is nothing but minus of 1 by 4 pi epsilon naught q dash by r square. See, force on q, this goes like this, no? O to C. This gets repelled, no?
Yes, sir. Yes, sir.
Any doubt? Now this is minus of this, no? So what I can say? Can I write like this? C to O. Understood this? It's minus of. Minus
Yes, sir.
AB is what? BA only, no?
Yes, sir. Yes, sir.
Yes, sir. We.
See, this year, be regular to classes, get your doubts cleared, okay, and get a seat and get out. Like last year, don't be lazy.
Yes, sir.
Any doubt?
No, sir. Clear.
Right, then we'll continue tomorrow. Go through this, okay? See, in 1 or 2 days, I'll post the assignment. Is it clear?
Yes, sir. Oh, clear.
Yes, sir.
Right, then we'll meet in the next class tomorrow, okay? Right,
Thank you, sir. Take care, sir. Bye, sir.
bye bye.
Thank you, sir. Bye.